Problem 17. 7 cards are arranged as shown. Each card has 2 numbers on, with one of them written upside down. The teacher wants to rearrange the cards so that the sum of the numbers in the top row is the same as the sum of the numbers in the bottom row. She can do this by turning one of the cards upside down. Which card must she turn? These are our options. First, add the number in the top row. The total is 31. Now add the numbers in the bottom row. The total is 35. The bottom row is 4 more than the top row. When we turn one card, one number moves to the top and the other number moves to the bottom. So we need a card with numbers that are 2 apart. So let's see our cards. 7 minus 4 is 3. That's not our card. 5 minus 3 is 2. That's not our card. 5 minus 4 is 1. That's not our card. 5 minus 2 is 3. That's not our card. 7 minus 8, 1. That's not our card. 7 minus 3, that is 4. That's not our card. So 4 minus 2 is 2. That means G is our answer. That is option E. Problem 18. The numbers 1 to 9 are placed in the squares shown with a number in each square. The sums of all pairs of neighboring numbers are shown. Which number is placed in the shaded square? So we have number from 1, 2, 3, 4, 5, 6, 7, 8 and 9. What two numbers make it 15? So there are two numbers make it 15. 9 plus 6 and 8 plus 7. If we use 8 and 7, then it would not go with, because this is 7 and there is no 0 in it to add. So we will go with 9 and 6. So the number are lowering, so we will start from 9 and then 6. Next should be 6 plus 1, 7. Then next would be 2, because 1 plus 2 is 3. So we are done with 9, 6, 1 and 2. Then the next would be 7, that makes it 9. And I think we got our answer, that is option D. Let's finish this though. So next comes 15, which is 7 plus 8. Next comes 3, 8 plus 3 is 11. Next comes 5, because 5 plus 3 is 8. Next comes 4. So our answer is 7, D. Problem 19. Each of the 5 boxes contain either apples or bananas, but not both. The total weight of all the bananas is 3 times the weight of all the apples. Which boxes contain apples? These are our options. First, add the weight of all the boxes. 7 plus 5 plus 6 plus 2 plus 16 gives us 36 kilograms. Now the banana weighs 3 times the weight of all the apples. That means we have 1 part apples and 3 parts banana. That means that is equal to 4 parts altogether. Now divide this 4 parts by this. So we have 36 divided by 4 gives us 9 equal parts. So all the apples together weight 9 kilograms. Now look at the boxes, then add up to 9. So here we have 7 plus 2 makes it 9. And that is our answer, 1 and 4. Problem 20. Elena wants to write the number from 1 to 9 in the squares shown. The arrow always points from a smaller number to a larger one. She has already written 5 and 7. Which number should she write instead of the question mark? And these are our options. Let's solve this. So we are using the numbers from 1 to 9 only once. Above we have 7 and 5 taken. Now only 8 and 9 can fit above 7. Since the arrows point towards a larger number, we will place 8 here and 9 here. In the bottom row, the numbers must increase. So we place 4 and 3. Now the numbers left are 4 done, 3 done, 8 done, 9 done, and 1, 2, and 6. Now this box is the origin. So this has the lowest number. So we'll put 1 in here. Now we have to place 2 and 6. So now if we put 6 in here, then it would not follow the rule that it will always point from a smaller number to a larger number. So we'll put 2 in here and 6 in here. So our answer is option D, 6. Problem 21. The sum of the digits of a given 2-digit number is 12. If the digits exchange their places, then the new number is 18 more than the original one. What is the product of the digits of this number? These are our options. We need 2 digits that add up to 12. So let's list them. So 3 and 9, 4 and 8, 5 and 7. Now check the second clue. When the digit swaps, the new number is 18 more than the original one. So let's try. If we have 39, we swap it, it becomes 93. That's too much. Try 48. Swapping gives us 84. That's again too much. Then try 57. Swapping becomes 75. So 75 minus 57 gives us 18. So our digits are 5 and 7. Now multiply them. 5 times 7 makes it 35. So our answer is option C. Problem 22. George has some marbles in a box. Every turn he removes half of the marbles, adds 2, and then doubles the remaining marbles. After 35 turns, there are 148 marbles in the box. How many marbles did the box contain at the beginning? These are our options. Each turn, George removes half, adds 2, and then doubles. So, suppose there are 10 marbles. It removes half of the marble, so 5 remains, adds 2, becomes 7, and then doubles, it becomes 14. Let's take another example. Let's say we have 20 marbles. George make them half, add them 2, makes it 12, and then double it. It becomes 24. Do you see a pattern? So each turn it adds 4 marbles. So in 35 turns, it adds 140 marbles. At the end, it says there are 148 marbles. So 148 minus 140 gives us 8 marbles. So how many marbles did the box contain at the beginning? 8 marbles. Problem 23. Martin plays 3 different types of object: hexagons, squares, triangles, on 3 sets of scales as shown. What does he need to put on the left hand side of the third scale? This is the left hand side of the third scale for these scales to balance. These are our options. Let's look at each scale. First scale. 2 hexagons make it 1 triangle and 1 square. Second scale cancels this hexagon from both the sides. So 1 triangle equals to 5 squares. So 2 hexagons equals to 5 squares plus 1 square. So 2 hexagon equals to 5 hexagon plus 1 square. That makes us 6 square. That means 1 hexagon equals to 3 squares. On the third scale, we have 3 hexagons. That means 3 hexagons equals to 9 squares required. 2 triangles equals to 10 squares. So 1 triangle is 5. So 2 triangle is 10 squares. So we have here 9 squares and we have 10 squares. So to balance them, we need 1 more square. So our answer is option A, 1 square. Problem 24. Berta has a shape made up of 4 glued squares. She places the shape on a grid figure so that it completely covers 4 of the grid cells. Every time Berta does this, she increases the number in the 4 covered cell by 1, as shown below. Starting with 0 in every cell of the grid, Berta places her shape several times as described. In the end, Berta had some numbers with the circle stickers. What is the largest number in her last figure? These are our options. So let's view this picture widely. Let's see a wider picture. Each number shows how many times that cell was covered. The top left is 3, so the first square was placed 3 times. The left cell in the third row is 2, so the next square was placed 2 times. And 3 plus 2 makes it 5. The center cell is 6. That means we already have 3 plus 2 in here, 5. So the third square was placed 1 more time. This becomes 3 and this becomes 6 now. On the right, 4 shows the next square was placed 4 times. That means we have 4, 5 and 5 here. At the bottom, the 2 and 1 has 2 more placements. So we have 2 in here, that becomes 2, and then we have 1, so this becomes 3 and this becomes 3. Now, since the cell marks 3, that is still missing 4 out of it. So we placed 4 times to make it 7. So 4 plus 4, this is 8. This is 5 plus 4 makes it 9. And this is 6. So the largest number in here is 9. So our answer is